Greetings, welcome, hello, how are you? Right now, we are into implicit differentiation. It's the second day, so the problems are going to get a little more complicated, but the method will be the same. And we're going to start off by looking at one of the problems that shows up on the AP Calculus exam. This is one from 2005, but pretty much every year there's going to be a problem like this on the AP exam. And so what they do typically is they'll start off by giving you some sort of an equation like y squared equals 2 plus xy, and they want you to show that this is its derivative. So they've done, they've given you it's a case where they've given you the question and they've given you the answer. Your job is to do the work that comes in between. So as we do that, we notice that we'd have to do some implicit differentiation to work this. So if we start off with y squared equals 2 plus xy, well, the derivative of y squared is 2y, y primed. The derivative of 2 is just going to go away to 0, and then this is xy, so it's a product. And the derivative of x times y is the first times the derivative of the second plus the second times the derivative of the first, which is 1. So, and every single time that I may have said this before, every single time that you differentiate x times y, you get xy primed plus y. Every single time. So you may as well just get used to that. So now our process is the same, and we're going to just try to get all our y primes on one side and do the factor trick and all that. So we're going to get 2y y primed minus x y primed equals y, and extend. And so then factor out the y primed equals 2y minus x, or y primed times 2y minus x is what I really meant to say there, and then I'll divide, and y primed equals y over 2y minus x, which is, lo and behold, what they said we should get way back up there. Okay? So there's the first part. Second part says find all the points x comma y on the curve where the line tangent to the curve has a slope of 1/2. Well, the tangent line's right here, so we need to find out all the points where the tangent line has a slope equal to 1/2. So where is the slope, which is this, equal to 1/2? So where is y over 2y minus x equal to 1/2? Well, let's do a little cross multiplication, see if we can figure that out. So where is 2y equal to 2y minus x? Right, so I cross multiply, and so I subtract. So where is negative x equal to 0, or where is, I guess the only thing is when x is equal to 0. And so when x is equal to 0, the y coordinate would have to be, let's see, if x is 0, 0 times that's that, 2, so we get y squared equals 2. Y is the square root of 2. Okay, and I think since we're going y squared, we should consider the positive and the negative roots. Okay, so there's that part. Check. Got that part. Show there's no place on the line where the tangent line to the curve is horizontal. Okay, show that there's no place where the tangent line to the curve is horizontal. In other words, there's no place where the derivative is going to equal 0. So I'll extend a little bit more. We'll go smaller. So y minus y over, I'm having a hard time speaking today, is equal to 0, or y is equal to 0. Is it possible that y is equal to 0? So is it possible that 0 squared is equal to 2 plus 0? So let's go back in there. Y squared equals 2 plus xy. So if I make y equal to 0, and I'll extend one more time and things get smaller and smaller, 0 squared, is that equal to 2 plus x times 0? Is that ever possible? Can 0 ever equal 2? Okay, so not possible. You say in some foreign language. So there's that part. We're going to skip part D because that's a little later on. That gets into the related rates, which we'll get. Maybe we'll come back to that at some point. But this is just a typical sort of AP problem dealing with implicit differentiation that you can easily handle. Okay, and even if we only did the first 3 parts, we'd probably have 6 or 7 of the 9 points available, and that would be pretty darn good. So onward. Find a horizontal and a vertical tangent for this. Okay, and there's the equation, and this is actually what this looks like. It's a three-dimensional sort of curve in 3 space, 3xy plus 6x squared minus 4y. So in order to find the horizontal and vertical tangent, we must take a derivative. And so we'll start. So here's a little thing. I would, if I'm taking the derivative of 3xy, I would put the 3. Okay, and I don't know if I've mentioned this before, but the derivative of xy is always x y primed plus y. Okay, and if I get the 3 out of the way, then I can just distribute it back in. And then the derivative of 6x squared is 12x The derivative of 4y is 4y prime. The derivative of 11 is 0. So now 3xy, or 3xy prime plus 3y plus 12x minus 4y primed equals 0. And then we'll get all our y prime terms together, all our not y prime terms together. I'll do that in one fell swoop. 3xy primed minus 4y primed equals negative 12x minus 3y. And then y primed times 3x minus 4 equals negative 12x minus 3y. And then we're at the place where we divide, and we get negative 12x minus 3y over 3x minus 4. So we've done the derivative part. Now they actually want us to do some work with that. So in order to have a horizontal tangent, that's going to happen when the numerator is equal to 0. To have a vertical tangent, that's going to happen when the denominator is equal to 0. Okay, so let's go with the horizontal. Horizontal. That's going to happen when negative 12x minus 3y is equal to 0. Or when, let's go with negative 3y is equal to 12x. Or whenever y is equal to negative 4x. So there could be a bunch of them. So if we pick a value of x, and then the value of y is 4 times it, then that's when that's gonna happen. Whenever y is equal to negative 4x. So I guess that's anywhere along the line. Y equals negative 4x. We'd have ourselves a horizontal tangent line. Okay, for the vertical tangent, which is when the function would be sort of undifferentiable, we're looking at the bottom equaling 0. So when is 3x minus 4 equal to 0? And this one's a jolly hand clapper because this is something we've been able to solve since, I'm going to say, 3rd grade maybe? No, let's say 9th grade at least. So x is equal to 4/3. So when x is equal to 4/3, we have ourselves a vertical tangent. Along the line y equals negative 4x, we have ourselves a horizontal tangent. Implicit differentiation, a little extra work. Okay? Super. Folium of Descartes. We want to find the equation of the tangent line and the normal line for the folium of Descartes at 4/3, 8/3. Okay, and so in order to find the equation of the tangent line or the normal line, we need to know the slope of the tangent line. And so in order to do that, we've got to take a derivative. And so let's have at it. 3x squared plus 3y squared minus 6. And again, get the 6 out of the way and then just take the derivative of xy. And I don't know if I've mentioned this before, but the derivative every single time of xy is xy primed plus y. And then the derivative of 0 is 0. Same story. 3y. Ooh, forgot that. Hopefully you caught that. 3y squared y primed. Ooh, bad. So because I was just about to say gather up our terms, but let's just first rewrite it one more time. 3y squared y primed minus 6xy minus 6y. Don't forget that distributing the 0 in there. Gather my y prime terms. I'm going to be extra efficient and do the factoring while I'm at it. Like so. And then y primed becomes 6y minus 3x squared over 3y squared minus 6x. I think that's it. So there's my slope of my tangent line. It's also the slope of the normal line, or it kind of will get us the slope of the normal line. And so what we need to then do is just plug in 4/3, 8/3 into it. So we're going to evaluate that, and that little bar, of course, means evaluate at 4/3, comma 8/3. Okay, that'll get us the slope of the tangent line. And then once we have the slope of the tangent line, we're just going to use our good friend, the point slope equation, mx like so, y minus y0, like that, and go for it from there. So I think this is just kind of monkey work, so you can plug the numbers in and get the answer. Once you have the slope of the tangent line, we know that the normal line, tangent and normal are opposite reciprocal slopes, right? Silence. Okay, as the tangent and the normal line have slopes that are opposite reciprocal, so you can work that the rest of the way through. It's the implicit differentiation part that we're focusing on today. And finally, the second derivative implicitly. Okay, this is really not that bad. Let's go for it. So x squared plus y squared equals 36. We need to find the in order to find the second derivative, we've got to find just the first derivative. So let's do it. 2x plus 2y, y primed, equals 0. Okay, and so then 2y, y primed is going to equal negative 2x, and then y primed is going to equal negative x over y. Piece of cake. Now, second derivative. Second derivative, we're going to take the derivative of the first derivative. Notice our first derivative is a quotient, so we're going to have to use the quotient rule. Okay, and so let's get to y primed, y double primed equals. Okay, so ho d high, so ho d high minus high d ho all over ho ho, right? And so I've got myself y double primed equals negative y plus x y primed over y squared. I know what y primed is, right? So y double primed equals negative y plus x times negative x over y all over y squared, right? Okay, and so then I've got y double primed equals negative y minus x squared over y squared, and I want a common denominator, so I'm going to go over this way. Y double primed equals, my common denominator is going to be y, so I'm going to get negative y squared minus x squared all over y. Take a second to make sure that that's okay. All over y squared. Okay, that is an awful looking fraction. So if I do the, divide the fraction, remember this over 1, so this y squared is going to be part of that, so I'm going to get negative y squared minus x squared all over y cubed, which seems like we're getting pretty close. And then I'm going to get negative x squared plus y squared over y cubed. Just factor the negative out of there. And then, here's the million-dollar question. What is x squared plus y squared equal to? Give you a second to think, look around. Okay, it's right staring you in the front of the face. X squared plus y squared. What is it equal to? I heard somebody say it. I heard several people say it. X squared plus y squared is equal to 36. So, negative 36 over y cubed. That is my second derivative. My first derivative is negative x over y. My second derivative is negative 36 over y cubed. Again, talking about how it's the rate of change of this particular curve, which is x squared plus y squared equals 36. It's just a circle with a radius 6 centered at the origin. So how it changes depends on where we are as we're moving around, and the way it changes is based on the y coordinate more than anything. Okay, the concavity. Ooh, got ahead of myself. So I think that's the story for today. It is. That's just information you don't necessarily need, but that'll be about it. So we want to get better with doing implicit differentiation. That's why we're spending the second day on it. We want to dabble with doing the second derivative implicitly. As you do the second derivative implicitly, it makes you better at doing the first one. And that, my friends, is the end of the story. I hope you've enjoyed our little journey today, and I hope you learned something. We will be talking to you, I'd say, fairly soon. Thanks.